and welcome to Cherry Pie Math. This video is going to introduce how we would represent quantitative data. So before we get started, you do need to know how to find the mean, the median, and the mode, which are measures of center, because quantitative data deals with data that has quantities or numbers. And those are how we deal with those numbers, is mean, median, and mode. So let's pretend that everyone in the world, every single person, all 7 billion of them, gave you their height. How would you organize that information in your brain? So just take a minute and think about how would you have billions and billions of data points. How would you deal with that? So in this video, we're going to be discussing how you would deal with that information. So prior to this video, we've talked about different ways that we would represent that information with categorical data. Two ways that we've done it is dot plots and bar graphs. So dot plots and bar graphs are a way to visually represent categorical data. But more importantly, they also help you with discrete data, which I'm going to go over the difference between them. So categorical data is data that's not numbers. It's just it's like favorite ice cream flavor, for example. In quantitative data, you can still use bar charts, and even you can actually still use dot plots depending on what kind of data you're dealing with. We have two different kinds of data. We have discrete and continuous, and there's overlap. So I guess discrete data can be for either categorical, which again means just like non-number data. So it can be for either categorical or quantitative data. It means that there's no in-betweens. So for example, discrete data would be like favorite ice cream flavors, because you don't have anything in between like chocolate and like strawberry, right? I guess you can mix them, but like when you're asking the survey questions, you're just going to ask for one or the other. It's discrete. There's no overlap. There's no like in between numbers. Or like in a quantitative scenario, it would be like asking how many meals you had today, or how many times you ate food today, because that would be, there's no overlap. You're not going to say I ate 3.62 times, right? You're going to say I ate 4 times, or I ate 6 times, because anytime you ate food, it would count, right? So that's discrete data. It means that there's no in-betweens, whereas continuous data is only for quantitative, because it has stuff in between. In between values are possible. So for example, height would be continuous, because you could be 6'2", or you could be 6'3", or you could be anywhere in between, right? There's no stop. There's no gaps in between the different options, I guess. So that's another way to say it. There's no gaps. Whereas discrete has those gaps in between. We often use, you'll see discrete and you'll see continuous data in different scenarios. Both of them are incredibly useful. Continuous just means that there's an infinite amount of possibilities, I guess, because you can have infinite amount of options between your base values, I guess. So let's look at some examples. So this first one, here's the data, is customer satisfaction out of 5. And for the sake of argument, I just said that there's no 0.5s, so you can't say 3.5 or whatever. So this would be discrete. And it's quantitative. Actually, both of these are quantitative. Because they both have numbers. So the first one's discrete because there's no overlap, there's no gaps, or there are gaps in between the numbers, sorry. So if I was to make a bar chart of that, I would, let's see, I have 1, 2, 3, 4, 5. And let's start with 1. So 1 appears 1, 2, 3, 4 times. So we'll do this. 1, 2, 3, 4. So that appeared 4 times there. And then I would do 2. I have 2 here, once, twice. I think that's all of them. And then I would look at the 3s. I have a 3, a 3, a 3. I have 3 3s. Then I have, let's see, 4s. I have 1, 2 4s. And then I have 1, 2, 3, 4, 5, 6, 7. Looks like 7 5s. So 5, 6, 7. And then I would draw my bar chart. So this would be a bar chart for my discrete data. You can still use a bar chart even if you don't have discrete data. So in this next one, I have some heights given to me in centimeters. This would be continuous because there are no gaps. You can have anything in between. The only difference with a bar chart in this case is instead of having it for each individual part, because you're not really going to find the same height twice. Like this one is the only time that happens. Most of them should only appear once. So you, instead of having each one listed, you're going to have it grouped into groups, because that way you're able to compare which groups. So we actually call that a histogram. And there's a couple of different ways to design it. Most of the time you have the bars right next to each other to show that there are no gaps. It's a continuous data set. So let's say I'm going to have, let's see, 160 to 165. And then I'll have 165.1 to 170, 170.1 to 175, etc. Sound good to everyone? Okay. And that allows me to have about 5 centimeters per group. So I have 160 to 165, and then I have, actually, here's what we're going to do. So in a histogram, what you basically do is you have your number line. I don't know what happened there. There we go. Okay. And then you're going to fill in between. So let's see. I'm going to just mark them and then I'll make it prettier later. So I have 170 is right here, but I'm going to group it here. Yep. So I'm just going to erase that. We're going to pretend like it's 0.9. Okay, so I have that. I have 188, 150.7 is way down here. 180.5, 167, 168, 170, 170, 174, 184, 183, and 163. Okay, so I just made some tally marks to show how many are in between. And then what I do is I'm going to say, okay, I have 1, 2, oh, these are too big. 1, 2, 3, 4. And then my bars are going to look a little bit different. Instead of stacking them on top of the tick marks on the bottom, I'm going to do it in between the tick marks to show that it's the range between them. So between 160 and 165, here's 160, here's 165. I have 2 people, and so I'm going to mark that as 2. And then in the next interval, I have 3, so I'm going to mark that as 3. Next one, I have 4, so I put 4 in that interval. And then I had nobody in the next interval, and then I had 3 in this one. I had 1 in this one, and then I had 1 like way over here. This little shorty. When I did this in middle school, my teacher had us all stand up according to our heights, and he called me freakishly short, and I still remember that. I am 27 years old, and I still remember that he called me freakishly short. So for all of you that may or may not be short or may not be tall, you are not a freak. Just to be clear, I don't know why he used that word. It stuck with me my whole life, and I'm pretty sure it's had an influence on my psyche. Anyway, so that's how you would kind of edit a bar chart for continuous data. You show that there's no gaps, and so all your bars are touching each other. And so instead of having each thing on top of one tick mark, you have it in between the tick marks. We also have this other thing called Box-and-Whisker plots. So when we use either kind of quantitative data, like discrete or continuous, we often use what's called a Box-and-Whisker plot because it helps us see kind of the spread. So if we kind of look back over here, you can kind of see there's like nothing on the sides, and then in the middle there's a lot more. And so it's spread out. The spread is how far apart the relevant, in parentheses, data is. Because sometimes like you'll have most of the data centered around it, and then you'll have like outliers out on the side. So when we have data that's super spread out, which measures of center is the best to use when there might be outliers? Do you guys remember? It was the median. The median is the best when you might have outliers because it's not as affected. Like the middle number will stay the middle number even if the last number is like 100 versus like 10 million because it's just by the amount of numbers. So to make a Box-and-Whisker plot using the median, you would have to first find that middle number. So the median, I'm going to do this in white. So the median is the middle number. The minimum is the least number. And the maximum is the most number. Those are the easiest ones to find, I guess, especially the minimum and the maximum. We also have these two things called the lower quartile and the upper quartile. And this is actually wrong. This should say Q3. My bad. This here is what we call the interquartile range. And what that basically means is like, so you have your set of data, right? And I'm actually going to just kind of draw a Box-and-Whisker plot. So you have your minimum and you have your maximum. And then you have the middle here-ish, depends on what your data is. And then you want to also find kind of what is the middle of those two sections. And that's what the quartiles are. So the lower quartile is the middle of lower half of data. And the upper quartile is the middle of the upper half of the data. Middle of upper half. This is super useful because most of the data we care about is not at the ends, it's the stuff in the middle. So the interquartile range kind of limits it to like what is important, what do we care about? It's in the middle. So let's try it. So I'm just going to go ahead and make all of these numbers really quick because you have to organize it to least to greatest. So go ahead and pause the video and then try to solve it yourself, and we'll compare our answers in just a second. Okay, so I just put all the data into like least to greatest, and honestly that will take some time, especially if you have a lot of data because you have to like keep track of where everything goes. But yeah, so you do that, you find the middle. In this case we had two numbers in the middle, so when that happens you add them together and then divide it by 2. That becomes your median. And then I found the middle of those two parts, and that's my quartile 1 and quartile 3. I don't know why I wrote quartile 2 for all these. These should all be Q3s. And then I have my minimum and my maximum, and those are pretty easy to find. The range and the IQR are two different things. The IQR is, or the interquartile range is the distance from Q1 to Q3. So you would do 94 minus 76 in this case. And that gets you, what, like 18, right? So my interquartile range is 18. And my range is my maximum minus my minimum. So it would be 100 minus 3, which is 97. As you can see, the range is much bigger than the interquartile range. That means that most of the students scored within like 18 data points. Whereas all the students, if you look at like the actual greatest minus the actual least, there's a huge discrepancy. That's why the interquartile range is so useful, is because it tells us like where is most of that data centered. Okay, now to make a Box-and-Whisker plot. So we have this data. What I want to do first is I want to put this on a number line. So I know that the least I have is 3 and the highest I have is 100. So I'm just going to go ahead and write 100 and like 0 on my number line, and I'm going to just do it by 10. So let's say 10, 20, 30, 40, 50, 60, 80, 90, 100. We'll just pretend like I didn't mess that up when I was making my video. Okay. And so then I want to put my median. I want to put all these data points. So I know one's at 3. That's like here. I'll put a mark there. I know one of them's at 100. I'm going to put my mark there. I know my median is at 83.75. That's like right here-ish. That's my median. We'll write that. My quartile 3 is 94. That's like here. And then my quartile 1 is at 76, which is like here. So I have all of these. That's my min and my max. And you don't have to label them, but right now it's probably good to just kind of get used to it. The reason we call it a Box-and-Whisker plot is because then we put a box around Q1 to Q3, quartile 1 to quartile 3, like this, because this shows this is where most of the data is. You do need to have that mark in where the median is. And then the whiskers are this part. So you just draw a line. Oh, I shouldn't have done that. And you draw a line from the box to the minimum. And this is standard practice throughout all Box-and-Whisker plots. So now if we look at it, we can say, oh, most of the data was right here. But there's a huge amount of space between these. And so if I was to like talk about this to my class, I'd say, oh, this 3 must be an outlier because whoever scored 3 must have just like put their name on the paper or whatever, right? This is the part that matters. As someone who's looking at data, this is the part that I would care about because I would want to see like where is 50% of my students, because there will always be some variety, at least in test scores, but if we can have a small 50%, that kind of shows a general trend that most of the people are around that spot. So some things to remember: bar charts are really helpful for both discrete and continuous data. Box-and-Whisker plots take some time. As we saw, I had to make like a whole other segment just to do this because by doing it by hand is incredibly annoying. But it makes a super nice picture, and you get to see what's the relevant data there. If you have 2 things in the middle, you just add them together and then take the average. I had to do that for the median. If you don't do it for the median, you will have to do it for the quartiles, and it really just depends there. Okay, I hope that helps, and good luck.